All right, in this video, we are going to go through 2.C fractional exponent rules, a DeltaMath assignment. So I'm just going to go through and do a couple of examples from each of the question types. So this is exponential radical form. And over here, I just have some scrap paper that I'm writing on virtually. So if you guys have some scrap paper, that might be helpful as well. So basically, we're talking about writing radicals in exponential form and being able to flip back and forth between them. So in Algebra 2, you learned very briefly about how to rewrite this as an exponent. And we learned that when you rewrite this as an exponent, your exponent will have the power over the index. And your index is the type of root that you're taking, while your power is the power. So if I was going to rewrite this using an exponent, I would rewrite this as x to the 4/3 because power over my index. And so then that would be my final answer. There we go. So your exponent is the numerator, the power, and the root, or the type of radical you're taking, is the denominator. Excellent. So let's try it again. This is a little easy section to kind of start you off. So, all right. So this way we're going the other way. So now I have x to the 2/7. So I'm going to write it as x, and then your power goes right here, and then your index goes right here. Right, so either way, hold on. I should actually rewrite them in the same colors as what I was just doing, or similar colors. So there's your power, and then here is your index, right? So the index, the type of root that you're taking, is on the denominator, and then the power is in the numerator. So if I'm going to rewrite it again, this would be the 7th root of x squared. And I can use the button on DeltaMath to help me with that. So this is the 7th root of x squared. There we go. All right, let's try it one more. Oh, exactly the same problem. Cool. All right. Oh, and this one is working backwards from that. So these ones were pretty easy, huh? There you go. So that's the first thing you have to be able to do. Now we have to be able to do simplifying fractional exponents type 2. All right, so now we're going to apply this. We can deal with fractional exponents now because we can rewrite them as radicals. But this one says simplify the following expression to simplest form using only positive exponents. So we'll just make sure that at the very end we only have positive exponents. 32, x to the -30th, y to the -15th, oops, -15, and then that's all to the -4/5. Okay, so right off the bat, I notice I have a bunch of parentheses with a power. So this is an exponential expression to another exponent. Powers to power. So I'm going to go ahead and see if I can distribute that exponent, and I absolutely can because I have no addition or subtraction. So I'm going to give that exponent here, here, and here. So I'll have 32 to the -4/5. I'll have x to the, when I have this exponential expression to another power, power to a power, and multiply those powers. So I'm going to do -30 times -4/5, which gives me +24. And then do the same thing with my y's, but I'm going to do -15 times -4/5. And I get a +12. And now I'm going to, I see that I have, oops, a negative exponent, so that actually belongs on the other side of my fraction. So I'll have x to the 24th, y to the 12th over 32 to the +4/5. And then we know we can rewrite 32 to the +4/5 using the power over index rule as 32 to the 4th and then the 5th root of that. I think I'm going to try just plugging this part in right off the bat because this says to the simplest form using only positive exponents, which is technically has everything with positive exponents. But again, it's just notation and weird notation. So 32 to the 4/5. Let's see if that will actually accept it as an answer. Nope. Okay, so yeah, you actually want to solve it out of the way. And so then here, I'll have the 5th root of 32 to the 4th. To get the 5th root in your calculator, you're going to you want something that looks like this. It's like n and then a root symbol. So you're going to go ahead and hit math, and then it is the 5th selection down. You'll see a little, oh, I guess it's not an n, it's an x, but so if you go down and you click that, then you can type in both the index and then what else underneath your root. And if I do the 5th root of 32 to the 4th, I get 16. So really this is x to the 24th, y to the 12th, all over 16. So I'll go back here and I can adjust that. And there we go. They show you how to do it if you didn't have a calculator and you wanted to move it step by step. So you can get 16 that way as well, but we have tools. So, all right, let's go ahead and try one more of these. All right, so I have 36 x to the negative 10 y squared all to the 1/2 power. And I look and I see, hey, I can absolutely distribute my 1/2 because there is no addition or subtraction happening. So I'm distributing that exponent and I'll end up with 36 to the 1/2 power x. When you have an exponential expression to another exponent, you have a power to a power, you multiply your exponent. So negative 10 times 1/2 is negative 5. And then same thing with your y's, 2 times 1/2 is a positive 1. I notice that I have a negative exponent, so my x is currently living on the wrong side of my fraction. So I'll end up with 36 to the 1/2 power y, and you can write the little one still if you want, over x to the 5th. And the last thing I have to simplify is this 36 to the 1/2 power. So I know I can rewrite that as 36 and then power over index y over x to the 5th. So this is really just the square root of 36, which we know is 6. So 6y over x to the 5th. 6y over x to the 5th. And there we go. Okay, let's go ahead and we'll try simplifying fractional exponents type 3. I actually went through and deleted this part of it, so that's why you won't see this on your actual assignment that you're trying, skipping the type 1. So we're just doing type 2 and type 3. All right, let's do it with this guy. Ooh, okay, crazy. All right, in this one we got 625x to the 1/4. 625x to the 1/4. I look and I see that I have multiple things inside my expression. Can I distribute the exponent? Absolutely, because I don't have addition or subtraction happening inside of those parentheses. So I have 625 to the 1/4 and then x to the 1/4. But I know that I can rewrite these, right? Because it'll be writing power over index. So I'll have 625 to the 1st power, and then my index is the 4th root. Same thing with my x variable, right? I'll have x to the 1st power. I'm doing the 4th root of that. I'm going to see if I can actually calculate this part in my calculator. So again, if you want to get to a 4th root, you hit math, and then the 5th selection looks like a little x to the parenthesis, or excuse me, x to the root. And so then you can go ahead and you can plug in a 4 for your index and then 625 underneath. And we get 5 times the 4th root of x. Wow, the 4th root of x. There we go. So we get 5, oops. And then here, this button lets me type in an actual index for my root. There we go. All right, let's try one more. All right, in this one I have 625 x to the 6 to the 3/4. Okay, I can go ahead and distribute that exponent because I have no addition or subtraction happening inside of here. So I'll have 625 to the 3/4. And then when I when you have an exponential expression to another exponent, a power to a power, you multiply those. So in your calculator, you can just do 6 times 3/4. Or if you actually wanted to multiply fractions, it's 6/1 technically times 3/4, which gives me 18/4. Okay. Oh, and that simplifies a little bit, doesn't it? To 9/2. So you can do it in your calculator, just literally hit 6 times 3 divided by 4, or you can practice your fraction math. All right, so then I get x to the 9/2 right here. And we're going to go ahead and rewrite these using our power over index rule. So 625 to the 3rd, and I'm taking the 4th root of that, times x to the 9th, and I'm taking the square root of that, and then we're going to simplify. So let's do this part we can do in our calculator. So math, 5th selection down, 4th root of 625 cubed would give me 125. And then here, when I'm doing, let me see if they will allow it. 125, that's a square root of x to the 9th. Oh, yep, nope, they're going to be grumpy about it. So technically, we learned the skill in Algebra 2 again. We won't run across it that much. And I actually would accept this as a final answer. I don't necessarily need you to simplify this. But when you're doing the square root of x to the 9th, it means you have 9 x's underneath here. And so they want to know how many pairs you can pull out. Right, so I have a pair of x's, a pair of x's, a pair, and a pair. So technically this simplifies down to 1, 2, 3, 4 x's, 4 groups of x that I pulled out, and then 1 x left over. So this will be x to the 4th, and then the square root of x. But you can use those skills as well. Oops. X. And if you run into some like extra hard problems that you can't do, like just let me know or send me a screenshot of the problem and I'll help work it out with you, okay? There we go. Awesome. All right, so that is this DeltaMath assignment for fractional exponent rules. Let me know if you have questions.